Hi, in this video, I'm looking at evaluating the multiplicative inverse of this matrix C, which is 2, negative 3, 1, 5. Now, before we look at doing that, let's have a look at how we calculate the inverse of the generic matrix. Let's call it A, with values A, B, C, and D. Now, the inverse of A, which is written A to the power of negative 1, is 1 over the determinant of A multiplied by what's called as the adjoint matrix, which is where you swap the terms on the leading diagonal. So we take the A and the D on that leading diagonal and we swap them. So we get D and then A on our new leading diagonal. And then for the other diagonal, where we've got B and C, we just make those values negative. So on my leading diagonal, I swap them. My other diagonal, they stay the same place, but we make them negative of whatever they already are. So if I'm going to go to my problem over here where I want to calculate the inverse of C, my first thing is to evaluate its determinant. Now remember, the determinant is known as doing A times D minus B times C, or the leading diagonal, 2 times 5, minus of the other diagonal, 1 times negative 3. So if we work this out, we've got 2 times 5 is 10, minus 1 times negative 3 is negative 3. So our determinant of C is 10 plus 3, which is 13. So now we know our determinant, we can now go and calculate our inverse. So C to the negative 1 is going to be 1 over 13, 1 over our determinant, multiplied by that matrix here, but at the adjoint version. So we take that 2 and the 5 and we swap them, and we get 5 up the top left and 2 down the bottom right. And then we get our other two values, the negative 3 and the 1, and we make them the negative of what they already are. So the negative of negative 3 is positive 3, and the negative of positive 1 is negative 1. And that is our inverse. Now you could multiply in the 1 over the determinant and get 5 on 13 and 3 on 13 and negative 1 on 13 and 2 on 13. But usually if it's a number that doesn't divide most of the terms within the matrix nicely back into integers, then we leave our fraction of our 1 over the determinant out the front. So really, we keep this as our answer because it looks nicer than this one with fractions all through it. But some people prefer the fractions all through it, and that's also valid. So there we go. To calculate the multiplicative inverse of a matrix, first calculate its determinant, and then write it in this form where we have 1 over the determinant times the adjoint matrix, which is swap the items on the leading diagonal and make the items on the other diagonal negative to what they already are.